Hi, hello everybody and welcome. Today we're going to go over doing a mock interview, um, practicing through LeetCode. So we're following the Super 30 curriculum and we're on the second unit on hashing. What I hope to gain from this is to get interview preparation when I have to do phone screens. The outcomes that I'm looking for is number one, I have to complete a LeetCode problem under the desired time of 25 minutes, and I think that will give me a good baseline of how I'll perform under pressure during interviews. Now, I must specify that the problems that I'm doing here, I've already done before. This is a practice round. But the point here is it's good review because I am revisiting problems that gave me trouble before. And in this iteration, I think I'll learn a little bit more. So I'm going to start the timer. I'm going to go through my process through pseudocode and then write code. Okay, um, let's dive in. Yee-hoo! Okay, so we have our problem, group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So, what's important to note here? I like to start off with a section, and we're going to call it the description. So we're going to write the problem description. We have an array of strings, and we call each string equals an anagram. This is our input, and our desired output is going to be in any order or unordered, probably some type of list, unordered grouping of anagrams. Sweet. Okay, so let's define what an anagram is. An anagram, for example, is something like this. We have eat, tea, and I'm going to just grab this text here. So this is what an anagram is. It's a string, and you can make different configurations of letters out of it um, with the same letters. So if we have a string called eat, we can rearrange each letter within the string in order to form a new string, and that would be considered an anagram. So eat and tea are anagrams, tan and probably nat are anagrams, and bat is probably its own separate anagram. So what we have here is a string problem, an array of strings problem. And so when we have an array of strings, or just an array, our kind of like problem-solving techniques that we have available to us is first and foremost, we have a linear search, or we have a linear search, we have two pointers, we have available to us a binary search, we have hashing, we have kind of like a bucket sort, we have this input may be sorted, maybe not, we have a sort available to us, sort and then scan. So these, off the top of my head, these are the techniques we could possibly use to solve array problems. Now, what I want to do is I want to go over, what I want to rule out classes of techniques in this problem. So in this problem, it's a string problem, so we're probably not going to use binary search. Binary search works well when we're working on a single value. And we're not trying to identify a single value. So that's not it. And we're not trying to find values. The next part is two pointers. A two-pointer is a linear search solution. It's just modified. And also we have sliding window too. But so a linear search, that would take, O of n time. But in this case, we have to make some notes. So particular to this problem, we have the following. We have to do a linear search over the array, and then in each index, we have to do a string search. So what that looks like is the array could be of size n, and the longest word could be of size m. So that would get us to do a linear search that would take O of n work times O of m work, and that would result in an O of m times n algorithm. Probably not optimal. So linear search, though doable, could be our brute force. Sliding window, not really the case here. We're not taking any ruling averages. So sliding window, you're out, bud. So 2 pointers, you're probably also out, bud. Sort then scan. That's interesting one. What would a sort and scan look like? Well, a sort and scan would look like this. Like it would take n log n time, and depending on our sort implementation, it might take linear space, n log n time to sort the input. And after we sort the input, we would sort each string here. So it would actually take n times log m time to sort. No. M times, no. Yeah, it would take m times n log n time to sort our input. Because we have to look at each string. So we can sort and scan. That's not a bad idea. Bucket sort, we are kind of putting, it looks like in our output, we're putting, like values in like buckets. Bucket sort, but not really here. That's not really the case. So what we've deduced is, maybe we have to do some type of sorting, some type of implicit sorting here. Possibly a linear search. I like this idea of hashing. So what would a hashing solution look like? Well, hashing would be, in a hash code, you want to, well, okay, so let's talk about what a hash table or a good hash function should do. A hash function should take your input and encode it to a different output such that there's a key and value. And the key, hopefully there's no key collisions because there's some order of randomness. And can we assume that here? And I'm going to play interviewer here, and we're going to say, yes, we can assume that with your key value you can definitely what do I want to say? Yeah, you can definitely assume some randomness. There's going to be no collisions. That's fine. That can be one thing. Okay, so what are we looking for now? So we could hash each value and put the value into a list. That's a very interesting idea. Like what we could do is maybe sort each word, which would take O of m log m time, and then hash each word and put the unsorted word in a list. So in this case, the key equals the hashed sorted word, and the value equals the unsorted word. And that's an interesting proposition here of doing this sort and then store. We would look over, we'd have to do O of m log m work, and then it would be a linear scans, and that would take O of n time. And that's not a terrible thing here to do. We're still keeping it, we're not doing O of n squared work or some type of exponential work. I like that idea. So what are the downsides to this? Downside, it takes a little bit more space for the hash map. It's a little cleaner because in my case, what I'm looking at, we can neatly define what are anagrams, because we're grouping by anagrams already, and we're storing them into a list, assuming that our put operations are constant. Um, I really like this solution. So let's state the complexity. Um, uh, so complexity, the initial complexity. And the initial complexity is going to be, like I said, O of m log m work for sorting each word. And then it's going to be O of n work to do a linear scan. Okay, cool. This is time complexity. Now space, it's going to be O of 2 times n, which in our case is going to be O of n space. Yay. I say 2 times n because, we need to have, some auxiliary space for sorting, and then our hash map takes O of n space. So we drop constants, can be O of n. That's our initial complexity. The things that we really need to look out for in this is thinking about optimizations. So some of the optimizations we can probably make, we could probably get away with, what would be a, Yeah, I'm really trying to think here of what an optimization could be. Initially in my head is we don't have to do hashing. Um, Sometimes we may have so much data that doesn't fit in one hash map. And in that case, we might run a MapReduce kind of function for grouping anagrams. But if we're just only have one machine and we need a hash and we have an unknown size, maybe that's not advantageous. Maybe we want just to do no, I think it'll be fine. We'll revisit this as we go along. Okay, so what I like to do after my problem description section is I like to run through a quick example just to, see if we get the right, the right kind of thought process, and we need to change anything. So what we're going to do is we're going to, have this example here. We're going to paste it down here, and what we're looking for is this output. Okay. And before we move on, I'd ask the interviewer, hey, is there any questions? I don't want this to be a talk at you experience. I want to collaborate on this. Okay, so for example, we have something like ET tan 8 nat bat, and our output should be some grouping of lists. And so want grouping of anagrams via a list. So what we do is, like we said, we would sort each word and then hash it. So, eat would become, EAT, T would become EAT as well. And then we would convert this as the key. So key equals EAT, and the value equals the list, which is going to be eat. The key in this case would be EAT, and the value, because a list already exists, we would say that equals eat and t. Cool, and it doesn't really matter the order. They said it's unspecified. And then we would go on and so forth. And at the end, our output would look like this. Not bad. Actually, our hash map would look like this. ATN, right? And then AET. It would look something like this. So then our next step would be convert the hash map to the list. So get all the keys. Get all the values from the hash map and insert into a list, or you know, something like do some conversion. Okay, that looks all good. I want to write some pseudocode, some quick pseudocode, and then we'll code this up. So here we go. If there are no questions, here's what the pseudocode is going to look like. Given an array, do a sanity check on the array. You know, the sanity check is like, you know, if the array is defined and not, or and is not defined or is empty, return an empty array of strings, or return a list of lists of strings. All right, that's the sanity check out of the way. The next part we have to say is, okay, we do have a valid array. Let's get to it. So what we need to do is we need to create a hash map. Create a hash map, and we'll just called dictionary, and we'll call it D for short, and it's ordered by a string as the key, and the value equals a list of strings. And what we want to do is we want to first, you know, iterate over every word. Yeah, we iterate over every word. Yeah, iterate over every word. Declare a for loop and iterate over every word. When we iterate over every word, that's going to be our o(n) portion, and then we're going to do for each word, sort that baby. Sort that baby. After we sort that baby, check, hey, does it exist in the hash map as a key? If it does, then put the value, or put the word at the index, at the current index. The word of, put the word of the current index, word contained in the current index of the array in the list. Okay, if it doesn't, else create a new list. Create a new list, and then insert the word into the list, and then insert the word as key and list as value. All right. We're going to do that for, you know, all keys, all words, and then at the end, you know, iterate over every entry in the, and iterate over every value in the hash map. Oh, wait. Declare a list of lists of, you know, some unknown type. Could be a string. Who knows? I think it should be a string of some strings. And iterate over every value in the hash map, and place those lists inside the list of some strings. Actually, we'll call this inside big L, and then return it. Return big L, baby. All right, we've got some pseudocode out. You know, it felt like a really easy process. What I mean by easy, going over my pseudocode, it looked like I didn't run into any speed bumps where there were edge cases I was considering, or a piece in my logic or understanding of the problem that didn't make sense. So I'm going to review one more time to see, and I'm going to review the pseudocode one more time to see if there's anything that I need to cover again. So given an array, yes. Do a sanity check on the array if the array is not defined, or is empty. Return a list of strings. Yes, good job. Create a hash map called dict. Good. Key is the string. Value is a list of strings. All right, declare a for loop. Okay, that's fine. For each word, you want to sort it, and then replace it in the map. But yeah, I think it looks fine. So right now, I'm gonna code it up. Code it up. So in the coded up portion, I like to add some test cases. So to see if we get the right output, and we can run it by hand, or we can run it, by some type of editor later on. We can put the output. We can run our test cases on some type of test automation suite that goes over our stuff, but I want to do it by hand first. So these are 2 test cases. We're going to see what happens. So code it up. Code that baby up. We're going to call this class. We're going to call it, oops, there we go. We're going to call it, let's say anagram. And with anagram, it's just going to be a public function that we can play with, and it's going to return a list of strings, and boy oh boy is Java verbose, and it's going to call it group, anagram.group. That's going to be what it's going to be. It is what it is. You know what I'm saying, son? We're going to call it an array, but really we're going to call it A because Java is verbose. So we're going to do sanity check. So we're going to say if a dot length equals 0, meaning it's there's no entries in it. We're going to, oh boy, here we go. We're going to declare a list of strings called L equals new array list of strings. And typically, like how I like to work in this case when I'm doing this code is I like to be quiet, silent when I'm writing. And then, if you have any questions that are like, hey, that looks interesting, we can talk about it. Or I'll write code, and then what we can do is say, like, at the end, you're like, oh, at the end of writing code, I can explain what I'm doing. Array list taking an abstract, I don't know, string, something like that. Cool. Okay. So we'll call this sanity. Sanity check, all good. Good, we're going to, so now what we're going to do is declare a result list, declare a dictionary. Hash map of strings and list. After we declare a dictionary, we're going to iterate over every word in our array. So for S and A. Let's do this. So group anagrams. Here we go. Let's group some anagrams. Here's how we'll group them. We'll say for each word, call it W. We're going to call sorted equals W dot sort. Then we're going to say dict dot contains key. We say, hey, after we sort our word, does our dictionary contain the sorted word? Else, do some magic. Does it contain it? Maybe. Hope it does. If it does, get it. Get it out of the dictionary. And we'll say, hey, oh, cool, we got it out, and we're gonna put this value in our list. Nice. Or we can say append. We can say just add it. Just add it to it. Just add it to the end, and then we'll say, all right, with this list, we're gonna put it back in our map. So dict dot put this given our sorted word. We're gonna put our list back in. I mean, because it's all in memory. Oh no, we're at 25. Really? That took 25 minutes? What part did we talk a lot on? I don't know. But let's keep going with this. Actually, I don't need to put it back. It's fine. Because we're operating in memory. Else, declare a new string called list equals new array list called strings. And then add this baby to the list. Add this baby to the list. Yeah. Yeah, this seems uniform. We could do this. Declare list equals that, or list equals this. Add it to the list. Nope. Can't do that. Cannot do that. Add that sucker to it. And then we'll do dict dot put with our sorted word as the key, put the list in there. And that's it for that part. And then here we go, create the result list. So we want to create a list of lists of strings, and we're going to call it result equals this bad boy. Result dot add l return result. Create the result list. So for every entry in our dictionary dot entry set. I don't know, get values. So it's going to be a list of strings, and we're going to call it another L. And dict dot, I don't know, values, something like that. Don't quote me on it. Result dot add L, cool, and then return result. Yay! Hey, listen, I gotta go cook now. This was a pleasure doing this with you. There is definitely bugs in here because I haven't touched Java in a while. But what I wanted to do after this is go over our test cases. After we do our test cases, prove the correct, that we have no bugs in here. And then I wanted to recap our time complexity and then open it up for questions if we could make any optimizations, possibly change the kind of input that we have, or talk about when this idea of grouping would be used in computing. Maybe not anagrams in particular, but just any type of grouping, because grouping into categories is incredibly important in computing. That's the time. Thanks so much, everyone, for watching, viewing. Let me tell you, this is the shitty version of, there's no production here. There's no production. There's no face to the camera. There's no like cool hip intro. I'm not playing some nice like lo-fi hip hop girl stuff. But it's gonna get better each time. So like, if you're still here and you made it to the end, hey, thank you for being A1 from day one. Um, Stick around. I'm going to do a lot more. The content's going to get a lot better. That's what I want to say. Um, Above all, I think Bucks in 6. No, I don't think so. I think the Suns are probably going to win. I mean, they're a balanced team. Number one, even if they had a healthy Giannis, it would be a competitive series. Uh, and I think in that scenario that the Bucks do win, Drew Holiday would get Finals MVP because he'd have to do a really good job on Booker and CP. I'd really like to see Giannis play D on Booker if he's this defensive player of the year. And you guys want to talk shit like, hey, okay, Booker would just head hunt, and then just get the switch. Okay, yeah, okay, that's fine. He could do that. But then you got PJ Tucker coming in, so I'd still like to see that initial matchup. Anyways, talk to you later. See you on the flip side.